Coming up on Dr. Kiki's Science Hour, we're talking about astronomy and hanging out with Fraser Kane from Universe Today. That's up next on Dr. Kiki's Science Hour.
Netcasts you love.
From people you trust.
This is TWiT.
Bandwidth for Dr. Kiki's Science Hour is provided by Cachefly at CACHEFLY.com.
This is Dr. Kiki's Science Hour with me, Dr. Kiki Sanford, episode 131, recorded Thursday, February 2nd, 2012. The Universe Explained. This episode of Dr. Kiki's Science Hour is brought to you by Netflix. Watch thousands of TV episodes and movies on your PC, Mac, iPad, iPhone, or TV instantly, all streamed directly to you, saving you time, money, and hassle. For your free 30-day trial, go to netflix.com/twit. Welcome, everyone, to Dr. Kiki's Science Hour. I am Dr. Kiki, and once again, we are here to talk about science. A whole hour on a pretty much single subject area in science with a single person. And today, I hope you're ready to dig in, ready to get dirty in the subject matter, because we're going to dig into the subject of astronomy. That's right. Space, the skies. It might be the places that I hang out all the time, but it seems like astronomy and the discussion of space is just about everywhere I turn these days. I mean, really, it might be the people that I follow on Google Plus or Facebook or the websites that I go to, but it could also be that it's just the topic of the moment. Everyone wants to know what is going on in space, what's out there. So to talk about the universe and everything that entails, our guest today is Fraser Kane. He is from Universe Today and Astronomy Cast. But first, I'm going to dig into science headlines for the week. According to a NASA study published in Atmospheric Chemistry and Physics, even though solar activity was at a minimum from 2005 to 2010, our planet absorbed more energy than it was able to radiate back into space. The imbalance was calculated at 0.58 watts of excess energy per square meter, more than twice the reduction of solar energy. The calculation was an improvement over past attempts thanks to a network of free-floating measurement instruments called Argo that allowed better ocean monitoring. Also, the results suggest that the Earth continued to warm during the measurement period regardless of solar activity, and further implicates human activities in the process. Scientists from Kentucky and Virginia discovered a millisecond pulsar as part of work done through the Pulsar Search Collaboratory, run by the National Radio Astronomy Observatory. Millisecond pulsars are the fastest spinning of the rotating neutron stars, highly stable, and more accurate at timekeeping than atomic clocks. It's hoped that observations of widely distributed pulsars will confirm the existence of gravitational waves. Scientists from the University of Exeter suggest that the evolution of land plants might have triggered major glaciations. The appearance of non-vascular plants like moss could have reduced CO2 levels enough to cause an ice age. Maybe it's the plants that did it. The last story, it should have started with high school students, not scientists. It was high school students who found that millisecond pulsar. Researcher Tara Smith found antibiotic-resistant bacteria, including the dreaded MRSA, methicillin-resistant Staphylococcus aureus, in both organic and conventionally raised pork. That's right, your organic, antibiotic-free meat is somehow tainted between farm and table. The question now is how and where. A study published in Science Translational Medicine might have found the mechanism behind the healing powers of massage. Tissue samples were taken from the legs of subjects who suffered through a grueling cycling workout and then were either massaged or not. The results of the analysis showed an increase in genes related to healing and a decrease in those involved in inflammation. UC Berkeley scientists can read people's thoughts. Well, listen in on them, at least. By recording and analyzing the brain waves of epileptic patients undergoing surgery, the researchers were able to create an algorithm that can recreate speech from brain waves alone. But so far, they still have to stick needles in your brain to do it. Scientists argued in the journal Nature that the government should regulate people's consumption of sugar. They stated that aside from obesity issues, sugar meets criteria for regulation just like alcohol and tobacco. It's unavoidable but has potential for abuse, is toxic, and negatively impacts society. What do you think? Let me know. That does it for the science headlines this week. Let me know what you think about the science news, or tell me what you think should be science news by emailing Dr. Kiki at drkiki.tv, or leave me a voicemail at 650-741-5454. Now for a word from our sponsor. This episode of Dr. Kiki Science Hour is brought to you by Netflix. Netflix streams thousands of TV episodes and movies directly to you instantly, which means that you save time, money, and hassle. We all like to save hassle. There are several easy ways that you can instantly access streaming movies and television instantly with Netflix. You can watch Netflix, movies, and TV shows on your computer, Mac or PC or iPad even. You can watch on your iPhone and some Android phones as well. If you have a gaming console, forget about the phones or computers, but maybe you have an Xbox 360 or a PS3, Nintendo Wii. You can watch Netflix right on your TV using one of these consoles. If you're not a gamer, but you have a Roku box or an Apple TV, you can watch Netflix right on your TV with one of these cheap and inexpensive devices. Inexpensive devices that are very easy to use. With Netflix, you can watch movies and TV shows instantly with any of these devices, and you can start watching on any one of them, stop wherever you need to take a break, and then pick up watching on another device right where you left off. That's one of the numerous pleasures of using Netflix. Whichever way you choose to access Netflix, you can watch as many movies and TV shows as you want, anytime you want, and you can cancel at any time. Try Netflix today for 30 days for free. Go to netflix.com/twit. That's right. Be sure to use this URL when you sign up for your free trial. netflix.com/twit. We thank Netflix for their support of TWiT and Dr. Kiki Science Hour, and we hope that you enjoy watching instantly with Netflix. Now, into the show, into the fun conversation that you look forward to every week. Fraser Kane is the publisher of Universe Today, a popular website that gets more than 3 million unique visitors a month. He's also the co-founder of the Keyword Strategy keyword management database for SEO. I wonder if that has something to do with the 3 million unique visitors a month.
Right.
Maybe.
Yeah.
Maybe, yeah. He's also the co-host of Astronomy Cast with Pamela Gay and has an asteroid named after him. And if you're into Google Plus and Google Plus Hangouts, you see Fraser all over the place. You've been playing with those Google Hangouts for a couple of months now, and I want to pick your brain about that. But before we do, Fraser, thank you so much for joining me today.
Well, thanks for having me. It's glad to be here.
Yeah, you're welcome. Tell me a little bit about how you got into astronomy and working on Universe Today. You yourself are an amateur astronomer, is that correct?
Yeah, I've been an astronomy fan since I was a little kid. You know, I had all these dog-eared books of, do you remember those like National Geographic books about space and astronomy? And they had like big spaceships on the front of them. And anyway, they were like my favorite, like Time Life, I think we get them by the mail. You know, the ones, yeah. So my favorite one was called Our Universe, The Universe.
That is, that's one of the best.
Yeah, and I
have to say.
And I, like I said, just read that thing to pieces, dog-eared. And then when I was sort of in my teens, I got a telescope. And the hilarious thing is, when I was in high school, I was writing, like I was in the journalism program at my high school, and I was writing articles about space and astronomy, about how to like see the night sky and stuff. And then I took a sort of a bit of a side turn into software development and doing website development and and consulting for clients. And I got to a certain point where I was working on, trying to help my clients with their websites, but I didn't really know directly what it was like to run a site on my own. And so I just picked one of my hobbies. So I'll run pick a site about space. And I was reading like The Case for Mars by Bob Zubrin and Pale Blue Dot by Carl Sagan, two books that were really influencing me at the time. And so I thought, well, I'll make a website about space and I'll learn more about space while I'm at it and be able to provide better sort of information to my clients. And as I went through that process, you know how this goes, it just kind of takes on a life of its own. And so, here I am like 12 years later, and space, it's all I ever do. So it's turned into quite a career. So whatever you like in high school right now, that is what you'll do for the rest of your life.
I don't know that is the case for everyone, but I definitely, from your story, I think that it's just wonderful to be able to do what your passion is, do what interests you. You've been able to put the computer stuff together with your interest in space, and you've created your own path in life.
Yeah, absolutely. I mean, I think that it's really hard. Anyone who runs a website knows there's like no money, which is sort of the problem because we're still waiting for the old media to give up all of the advertising bucks and be able to start, supporting this new media. And so you kind of got to be a jack of all trades. You got to take your love of computers. I have a computer science degree. You got to take your love of the technology of the medium that you're interested in and kind of blend it all together and do the work. So. Yeah, absolutely.
So
you can live your dream.
That's right. Live your dream.
Live your dream. Yeah.
Before the show started, we were coming up with mottos for Canada. So this could be the motto for the show for people. Live your dream.
Everyone gets to giggle. Everyone gets to giggle every time I say a boot. There, you happy? A boot. A boot. There. That's my Canadian accent for you. About how I really say it, but yeah.
Awesome. So tell me about the kind of stuff that you publish on Universe Today, and maybe some examples of recent stuff that has come up in the stream on the website.
Well, when I first started Universe Today back, like I said, about 12 years ago now, 1999, there was no real single space website that you could go to. So all of the major websites at this point have been doing their publishing for about 3-4 years. There was CNN and BBC and MSNBC and things like that. And they were all covering a certain amount of space news. They would have one story every day. But there's no one place where you could go if you just wanted the space news. And so people would have to go to all these locations. And so that was what I started by doing, was just pull together and summarize. And then it sort of turned into actual journalism after a while, where I was interviewing researchers and talking about their stories and getting, scoops and things like that.
Right.
And at a certain point you realize, and I think this is what all the big bloggers realize, the Engadgets and, IO9, and there's a lot of places that it's really about being as comprehensive as you can and as many stories as are required. And so we're at the point now where we're publishing sometimes 10 to 20 stories a day all about space and astronomy, because there's also kind of that much going on all the time, and it can be just quick videos, they can be really cool pictures that we like, or really in-depth interviews with astronauts and scientists and stuff we're working on and other stuff that people are doing as well. So we try to be as comprehensive as we can to get everything you would be expecting, all of the big exoplanet discoveries, all of the cool mission launches, things like that. And then we try to go one step further and dig up stuff that maybe you never would even have known about. We dig into research journals and try and get reporting directly from the researchers themselves. We're all constantly watching YouTube for really cool, time-lapse videos and things like that. So yeah, we find lots of good stuff.
Tell me a little bit, as you mentioned exoplanets, and so last week there was a whole bunch of news out about Kepler and exoplanets, and this week in the news there's giant Earth found. It's one of the most likely candidates for being similar to the planet that we call Earth, and blah blah blah. What's your take on all of the exoplanet news?
Well, I think it's so exciting.
Yeah.
Just think about this. Was it like 1998 was like when the first time that, planets were discovered orbiting, was it PEG 51? And so we're only 10 to 12 years into this sort of modern era of planetary discoveries. And the number that we're discovering are just accelerating. So we're at, we're now into the thousands of planets discovered. And the kinds of planets that are being discovered were completely unexpected. I mean, the hot Jupiters, these enormous planets that orbit within, closer than Mercury to their host star. You've got weird, combinations of orbits where it's like little planet, big planet, little planet, big planet. You've got planets going around, star or double systems, right? Like Tatooine, right? So you've got all these really weird things. And now, finally, with Kepler, we're getting to the holy grail of planetary discovery. This is where we find Earth-sized planets orbiting worlds within that planet's habitable zone. And so far, we've gotten kind of half of the story twice. I say we. Kepler astronomers have discovered these amazing, Earth-sized worlds orbiting other planets. So you've got, in fact, even smaller. They found Mars-sized worlds, Mercury-sized worlds orbiting other planets, or orbiting other stars. And that's sort of on the one side. And then on the other side, they've been finding these planets that are orbiting within the habitable zone of their parent star. This is the place where you can get liquid water on the surface of the planet. And so really, but the worlds are really large and possibly not suited for life, although maybe that's not true anymore. Some really interesting research that's just come out in the last couple of days to sort of refute that idea. And so, as you said, the Holy Grail, and I think it's going to happen soon. In fact, we've had this discussion with some of our space friends that data already exists inside the Kepler database somewhere, and it's just a matter of time to confirm and so on that this, within the next couple of years, you're going to get the two coming together. You're going to get an Earth-sized world orbiting within the habitable zone of its parent star, essentially another Earth.
Which is such an exciting idea. I mean, conceptually, from the idea that if there's another Earth-like planet, if it's the same size, same relative distance from its star, maybe there's water on it. Maybe if there's water, there's life. Maybe it's advanced life. Maybe it's maybe it's just microbial. Maybe it's early on. But there's that idea that lingers there of maybe we found a location where life other than humans could and life on Earth could exist in the universe.
Well, there's this problem, though, is that once you get this, you said that, scientists have found it. We found an extrasolar planet, Earth-sized, or, located within the habitable zone of its parent star. And then the next question everyone's going to want to know is, does it have life on it? And the reality is that under the current technology, there's no way to know. And so that, unfortunately, and this is sort of part of the problem, is some sort of missions, some really important missions got unfunded, defunded, canceled, that could have taken the next step to answer that question. Because the only way to know if there's life on one of these planets is to use a very powerful telescope and to actually look at the chemistry of the atmosphere of that planet.
Right.
And once you do that, there's certain kind of chemical signatures like, free oxygen in the atmosphere or methane and things like that, which can only be that are so they want to combine so much that they can only be the byproduct of some kind of organism. And so if you see oxygen in the atmosphere of a world, kind of like what we have here on Earth, then you would know. And unfortunately, the kinds of scientific instruments to do that, they're not coming at the next level. And so we're going to find all these planets, but not be able to really confirm the existence of life on them until the next set of missions come out. So
right. So I know that we've been doing that kind of analysis for on Mars, and that we've been looking at the atmosphere of Mars. At first it was, okay, so is there liquid water on the planet? Let's look at the atmosphere that remains around Mars and see what's in there. And they were finding methane or sources of methane that they think could come from biological sources as under the ground, as opposed to chemical processes that would occur naturally. And so I know that we've got that for kind of short range within our solar system analysis. Is it just that looking at these potential planets, exoplanets around other stars, will it be so far away that we just don't have the resolution to do it?
Yeah, that's part of the problem is that it's just, I mean, you're attempting to detect the atmosphere of a planet orbiting another star that could be 50, 100 light years away. The kind of technology, the size and scale of the telescope that would be required is pretty phenomenal. So there's going to need to be some very specialized instruments to do this kind of work. So it's just a scale thing. I mean, the techniques of detecting these planets are so exquisite. They're finding some of these worlds hundreds of light years away from us, way further than anyone ever thought they would be able to detect them, just because Kepler is just such an incredible space telescope. But it's that next challenge. But there's some really interesting stuff as well. Like, for example, the SETI Institute is planning to work with the Kepler team.
I was going to ask you next about that.
Yeah, so they're going to work with the Kepler team to target their instruments on some of the candidate worlds that get turned up by Kepler. So you can imagine there's this, instead of trying to scan the whole sky or find stars that are kind of like the sun, they're going to be able to point their telescopes directly at worlds that are very analogous to Earth. And so there's a really much higher chance of there being life and some kind of intelligent civilization there than just choosing worlds at random. Because I think a lot of people don't realize with SETI, it's very much searching for a needle in a haystack.
Yeah.
You don't just, point your radio telescope at the sky and listen for signals. They're actually going and pointing this really powerful telescope at a specific star, and then they're only scanning certain bandwidths from signals coming from that star. So it really is hard to get a really wide view of the whole sky. And so if they can get some good targets, that'll be really great.
Yeah, I think having the specific targets as opposed to going, okay, well, this might be in an area that is likely, so let's try here. Just kind of the random discovery as opposed to the very specific selected search process.
Yeah, and I mean, either way the question goes, the answer is very exciting. I mean, you can imagine the next 5 to 10 years, if they keep looking and they just don't turn up anything that is life, then it starts to make you say, well, maybe whatever happened here on Earth is very lucky, very random, and there's probably not a lot of life that's in the galaxy. That's sad, but it is very interesting and it is very important. It tells us a lot about what kind of, how we have to take care of our planet and how it's almost our responsibility to get off this planet and start a spacefaring culture. Oh, go ahead. Yeah, sorry.
Yeah, I was just going to say this is a really interesting philosophical point because there are a lot of people who are interested in getting us off this planet, starting a spacefaring culture. Newt Gingrich is saying we're going to build a place on the moon. We're going to have what's the word? I'm totally blanking on it. Mom brain.
Base?
Yes, our moon base. Yes, thank you. We'll have our base on the moon. Other people are saying let's go to Mars, and other people are saying, let's just get out into space and have spaceships that travel, and people who just live their entire lives on spaceships traveling to other solar systems. There's a point at which when people start thinking in that mindset, it's like, oh, forget about the Earth. There's nothing we can do about it now, and let's just focus only on moving away and not on caretaking what we already have. I don't know.
Yeah, well, I guess, I mean, I think that it's I mean, there are a lot of really good reasons why we need to turn humanity into a spacefaring civilization. I mean, the reality is that right now we have all of our eggs in this one basket. Some idiot with a, anthrax plague could wipe out civilization. You've got, sentient computers overthrowing their human oppressors. You've got asteroid strikes. You've got, who knows what could happen, and the
right.
Some kind of global, climate catastrophe. There's all kinds of reasons why if we can reach out into this, into space and set up humans on other planets, then we've got a backup. We've got, a chance to sort of continue human civilization. And so I know there's like a lot of people say, well, we're so busy focused on, here on Earth, why should we go into space? But I think that that's sort of a failure of imagination, that you have no idea what's going to happen next. It's like saying, we're so busy, living in our, we've got so many problems here in Spain that we shouldn't send ships over to explore what's across the ocean. I mean, you just, you just never know what's going to be out there and what the benefits are going to be. So there's tons of good reasons to get out into space, and I'm all for them. Yeah,
big proponent of space travel.
Yeah,
is it?
Yeah,
do you think more? How much more do we need to learn about space before we're ready to get out there and have targets to go travel to?
Well, we're never going to know everything that we need to know. And this is sort of part of the point. You always get this argument between should we have science missions or should we have human spaceflight, and there's always this argument between the two, which I think is kind of mean. It's sort of like making, two children fight over, candy, when it's really not fair. I mean, it's like it's completely two different conversations. And so, you get ready to learn how to do things by doing those things. And so the way we learn to become a spacefaring civilization is we send humans out into space and we figure out every single engineering problem and we fix them one after other until the whole thing becomes smoother and more dependable and more safe and everything is good. But I mean, the amount of money that's spent on space exploration in the United States is just like a fraction of 1% of the U.S. budget. So I mean, almost no money is spent on doing that. As they always say, more money is spent on microwave pizza than space exploration. So.
That's a good way to put it into perspective.
More interest is spent watching the Kardashians than spent on science. So, that's just the reality we live in. So if you want to pick things that maybe we shouldn't spend so much time on, I can give you a list.
We could come up with sending the Kardashians to space, and then we could talk about the science related to sending the Kardashians to space, and then suddenly everyone would be interested.
Well, then they'd be famous for doing something. Yeah, no, I think that's great.
That'd be awesome. This is a great idea. This is a big idea day for me. You as an amateur astronomer, how much do you see amateur astronomy having an influence on our knowledge of the universe today?
Well, astronomy is one of the few sciences, and you probably know this from your own experience, that the astronomy is one where amateurs play a huge role in pushing forward the actual scientific discovery. So beyond just people just taking cool pictures and looking through their telescopes, amateur astronomers are working day in, day out with established professional astronomers to actually do research. They're discovering supernova, they're finding asteroids, they are they're participating, doing variable star astronomy, and so now with a lot of the work that my co-host on Astronomy Cast, Dr. Pamela Gay, is doing, they're actually participating in research projects, through the internet, through the computer, which I can go into at length at some point if you want.
How about now?
Right now, sure. So what we're doing, or what Pamela has really been spearheading, is a lot of these online projects where you take researchers, for example, people who are exploring the moon or craters on the moon or looking for asteroids, and they are looking to get the help of the public. And this is at cosmoquest.org. And so you're looking to sort of pull together researchers and the public. And so the public can come in. There's a really easy set of tools they can use, and they can map out the positions of these craters, and then that data can be used by researchers that are trying to calculate the ages of sections of the moon and things like that. And there's plans to do work with the New Horizons spacecraft to help find targets for where New Horizons should go after it reaches Pluto. So there's a ton of these situations where you've got an enthusiastic group of amateurs who really want to help out with science, but they don't necessarily want to have to go and get a PhD, which I'm sure you recall was hard. It
was expensive and it took a long time.
Yeah, it took a long time. And so we really feel like there's a huge group of people out there who want to participate in science, but they don't have the wherewithal, they don't have the time, the money, the gear, whatever, to try and go and actually get their PhD, which in many cases is the way it works. You go and you spend all this time, and then you're allowed to do some research. And we really feel that for a lot of the kinds of tasks, you can teach people how to do the kinds of things that are necessary to help out with the research, and then bring those two people together. And so we're trying to, we're using CosmoQuest as a place where we can gather together the amateurs who want to participate, teach people the basics of what they need to be able to actually help with the research, and then take things to the next level as well. So you might get a researcher that needs people who are experienced in doing spectroscopy or identifying, extrasolar planets through microlensing, and so we can kind of bring these people together, and hopefully down the road, the kinds of skills that we'll be able to teach people will move them towards being actual practical astronomers and scientists. And so you can really sort of see the potential of this. I mean, the internet is just awesome for this kind of thing.
Oh, it's wonderful. I love the potential, especially like what you're talking about, the ability of people to get involved in the data analysis, the ability of people to be able to actually do image analysis, to be involved somehow, like you said, not have to get a PhD to be able to do it. It's just great. I don't know. Along with the internet, though, I think we need lots of in-person science stuff. And there's local stuff that you can get involved with, but in addition to something in your neighborhood, there's the possibility of doing stuff through an internet neighborhood. And you've been doing a lot of stuff with Google Hangouts recently. Something that I thought was really neat and I wasn't able to take part in the other day was an actual sky watching event that you did where you're looking through a telescope. People could hang out and like watch with the astronomers. And tell us a little bit about that.
Yeah, so what we've been doing, and this was sort of as soon as we started playing with Google Hangouts, my mind all gets buzzing, and I'm thinking about all of the potential for this kind of technology. And anyone who hasn't been playing around on Google Plus, a lot of this stuff is really exciting. I highly recommend you jump in, do some Hangouts. You'll kind of see where this is going. I hope Leo is taking notes because it's really cool. Yeah. And so what we wanted, I was seeing this, and one of my friends had a telescope, and I was saying, is there any way you could actually stream the view from your telescope into the Hangout, and I could sort of have a Hangout with people, but at the same time have a telescope, and maybe we could point the telescope at different objects and see what we can see. And he was like, yeah, I think so. And then, a few days later, we had a Hangout, and there it was, just a view of Jupiter just floating in the middle of the Hangout.
Nice.
And you're like, okay, this is pretty cool. And that is just sort of, we then went live. I'm one of the people on Google Plus that has access to this thing called Hangouts on Air. And so I'm able to broadcast the Hangout, kind of like what you're doing right here with This Week in Everything. And so then I was able to broadcast the view to the telescope, and we moved around to a couple of objects, very rough and haphazard, and we had a bunch of people watching, and they were just really excited, and then more people with telescopes started to reach me and said, oh, well, let's, I've got a great telescope. I'm in Arizona. I've got a telescope. I'm in Los Angeles. I'm on the West Coast. I'm in South Africa. I'm in Turkey. And so, and for those amateur astronomers out there, you kind of know that, because the Earth is turning, different objects are visible in the sky to different people at different times. And so we can have a person in, say, Los Angeles, just as the sun is going down, viewing Venus, and then somebody on the east coast of the United States viewing, say, Jupiter that's higher, or even Mars. But then somebody, as I said, a person in Turkey who is viewing Saturn that doesn't rise until, early in the morning. And so some of our tests now, we're up to the point now where we've got like 5 telescopes all going at the same time, and we're switching from telescope to telescope, and the setups are just better and better and better and crisper and clearer, and it's really quite exciting. And so we've had a situation. I think we did one just 2 nights ago. In fact, we might be doing another one tonight. we had, like I said, 5 telescopes. And so one person was viewing the Great Nebula in Orion while another person was viewing the moon, and I'm just clicking between. And then the other cool part is then we get, my partners in crime, Dr. Phil Plait and Dr. Pamela Gay. Phil Plait is a bad astronomer, and Dr. Pamela Gay is my co-host on Astronomy Cast, and they jump in, and then it's like we're doing color commentary on astronomy. And so we're talking about, and so Phil's got his map of the moon out, and we're figuring out what moons are, and we're looking at interesting impact craters and walls and chains of craters, and talking about the science that's going on and the different colors. And then we can switch over to Jupiter and look at the moons and figure out the positions of the moons, and then switch over to see the Great Nebula in Orion. Yeah, it's really exciting. I'm really enjoying this, and I really feel like we've barely even cracked the surface on where this is going to go.
It's such an amazing idea. I mean, I'm just sitting here getting goosebumps, just your description of being able to connect people from all over the world to have a simultaneous view of completely different portions of the night sky.
Yeah, absolutely. And for a lot of people, the view is better. We're trying to make it feel like it's a star party where you go into a star party, you walk around, and someone's got a telescope, and you walk up and say, oh, what have you got here? Oh, I've got a 8-inch celestron. Oh, can I take a look? Sure. And you look through the eyepiece, and you see Jupiter, you see Saturn or the moon. That's the feeling that we want it to be, but you don't have to leave your house. The skies are always clear, so it's been really fun. And we're at this point now, I think we've probably got about 15, 20 astronomers who are all able to show up at the same, some show up because they've got clear skies, some just show up just to hang out and join the chat and talk about the gear and help us talk about seeing. There's a ton of just learning about how to get pictures, how some of those really beautiful astrophotos are taken. So yeah, it's a really worthwhile experience. I'm really enjoying it. And, astronomy is my field, and that's what I have the connections in. That's the people that I know. But you can imagine almost any field. You can imagine researchers at Antarctica, oceanographers, volcanologists, weather researchers. I can just imagine the kinds of content that could be done in this kind of a way. It's really exciting. And so that's why, again, I say, if people think that Google Plus is not fun, then, come back, check it out again, and, circle me. And that way you'll get a chance to see all of the stuff that we're doing. And yeah, it's really exciting.
And in addition, your science circle is just fabulous. So in addition to circling Fraser on Google Plus, you want to circle his science circle as well.
Yeah, and I'll share that. If people are watching, then I'll share that in the next day or so. And that's a list of about 250 people who are active on Google Plus that largely talk about science and those kinds of topics. And so instantly, one click of a button and you've got 250 people talking about science. And if you love science, then this is a really interesting sort of group of people to watch and engage with.
Yeah, absolutely. I've come across some great people that I wasn't aware of as a result of your science circle and the hangouts that you're doing. What you're describing doing and what you're trying to do within the Google Plus environment and the Google Plus hangouts, it's really inspiring. And I'm trying to figure out how we could do hangouts for neuroscience. Can we do hangouts while people are getting their brains fMRI imaged? Can we do hangouts while researchers are looking at bacteria in a dish? Anything that you can hook a camera up to. Can we have some hangouts and actually talk about what's going on? And
yeah, absolutely. I think that what sort of the old media people didn't realize is that, or maybe they just couldn't support that, is that for certain people, some content is incredibly interesting. They want to see as much of it as they can. If that's what you're into, if you're into space and astronomy, if you're into science, then this kind of stuff is super fascinating and you love it. And same with, as you said, same with biology, same with neuroscience. I wouldn't want to watch that. I might turn the video off and just listen, but I get squicked out by autopsies, things like that. But I'm sure there's a lot of people that would love to watch an autopsy live on Google Plus. And so There was a conversation. I was talking to a guy yesterday, and he does these G-scale model trains, and he builds these fairly expensive, fairly complicated trains that are large, really big, and has this amazing sort of train set. He does a show on gets together a bunch of his people. They work on these trains, talk about the different engines. I mean, there's just so much stuff out there that you can do, whatever you're into. There was one guy, I know, the Reddit people really appreciate that. He was just coding in a hangout and talking about the kinds of code that he was trying to do. And so he would start with a challenge, and then he would code, and people could see the results of his code as he went. They could ask questions, and then at the end, he would get the code to run. And for a lot of people, that's exactly what they wanted to see.
Yeah, there's a huge educational, self-educational value in a lot of these hangouts. A lot of the hangouts are just hangouts, and they're just people doing whatever, and it's, not a lot of value. But there are a lot of people thinking in the way that you are about what the boundaries are to this and how can they push them.
And I'm a serial hangouter. So I will often see hangouts and drop in, or I'll start them and people will jump in and we'll talk about science and I really enjoy it. And so again, if you're on Google+, you're not really sure what it's about, start jumping into hangouts, start engaging with people. It's a really good time, and I think it's sort of taking this whole connectivity to the next level. Yeah, we are. You're taking it to the next level.
Tell me a bit also about what kind of do you have anything on the horizon for things that you're looking to do, or is it are you going to just play with it the way that you are currently and see where it goes?
Well, I mean, like I said, right now all of the live streaming telescopes that we're doing is all experimental, and so there's no rhyme or reason to it. No, we don't give any notice. I'm just like, oh, I'm running a telescope live, because often someone will say, I've got a view, and then I'm like, I'll put it live, and then we're on, and then it's very viral. People share it, and then people show up and watch it, and then we record it, and people can see it afterwards on YouTube. But I would love to get to the point where it's done on a more scheduled basis, where we know once a week we're going to crack open the telescopes and see whatever is up. And if people have clear seeing, then they jump in and join. And if they don't have clear seeing, then they sit this one out. And if we can get to the point we've got enough astronomers on deck, then we can be very regular about it. And I think people can kind of start to count on it. We can have someone in the daytime who's watching from another someone could be showing the sun at the same time, because you can have we have a nice round Earth. So that's my hope with that, is to make it a little more regular. And then we got some challenges we want to do. For example, there's going to be the transit of Venus in June 2012, which is the only time you're going to be able to see this for your whole entire life. So if you don't see this, it'll never happen. It's never going to happen again. We want to live stream that. Again, multiple telescopes around the Earth. Let's have some parties. Let's watch it and really celebrate it.
That's cool. Are you going to be sticking with amateur astronomers, or are you reaching out to any academic institutions that have telescopes, or is there can we connect to the telescope on the volcano in Hawaii?
Well, we've had some chats with some of the people. It's kind of funny because different telescopes are better for different things.
Yeah.
And so, in some cases, actually a small telescope equipped for planetary stuff is going to show a much better view of the moon or Jupiter than the Keck Observatory. It's just too big. It just, there's challenges there. And so, for what we're doing, the way we're kind of treating it is anyone who wants to come and be able to stream a view from their telescope into a hangout is welcome. And and so I'm trying to treat everybody just like peers and equals. And if you've come with a 14-inch telescope, that's phenomenal. If you've come with a 3-inch telescope, you're welcome. And it's more about making sure that it's inclusive and not trying, because we want to show a different sample as well. This is what you can get with a small telescope. This is what you can get with a really big telescope. One of the guys that joins us has got a $20,000 setup with a beautiful automated guiding system and a phenomenal camera. Another guy, the moon is kind of shaking because he's hand guiding his telescope. So that's part of the plan. One of the things we want to do, I'm sort of scheming, is usually in the spring you can do what's called the Messier Marathon, which is where you attempt, astronomers will attempt to view every one of the objects, the sort of blurry, fuzzy nebula and galaxies and globular clusters. And so I want to do them all at the same time. I want to do, 10 astronomers all going at the same time. We should get it done in an hour. What usually takes all night, we should have it wrapped up pretty quick.
And everyone can come in, hang out, and say, I did it.
Yeah, I did.
We did the challenge faster than ever before.
Yeah, exactly. You can imagine with bird watchers or something similar. You could just get them all going at the same time, and then boom, take an hour, done. You've seen all the birds. You're done. Moving on. So, yeah. And I think the other interesting thing that we're doing as well is, I think I noticed it was sort of on the screenshot, is we're doing our weekly space hangout.
Yeah.
And this is where we pull together. And this is sort of, again, an experiment. Who cares if it doesn't work? We're having fun. Where we pull together a team of all of the science journalists in space and astronomy all in one place and try to, we just talk about the various stories that are going on this week. And so it's great. We've got Ian O'Neill from Discovery Space News. We've got Phil Plait, Bad Astronomer from Discover. We've got Alan Boyle from MSNBC and Emily Lakdawala from the Planetary Society. And we've got open invitations to other space journalism luminaries. You know who you are. So I think that, it's a great way. Again, it's just sort of brings community together. I mean, obviously, we're all fierce competitors and want to destroy each other's businesses. But once a week, we can all come together and, and share our love of space and astronomy and talk about it and geek out.
Yeah, and that would be, it's a lot of fun to watch because you're coming from a place of passion and interest and years of thinking about this stuff, and everybody maybe has a slightly different take on the different news stories. Not everybody's going to agree on the subjects that you're talking about. There's going to be, maybe Alan has one, maybe he thinks Pluto should be a planet, and you don't. I don't know. I'm just making this up, but
yeah, and there's a great potential for using this kind of technology for actually doing your journalism. I mean, there's been so many interviews that I've done with astronauts and the heads of missions. Where I was like, boy, I sure wish people could have heard that conversation
as it was going,
was going on, because what we talked about. It's not going to go anywhere. It's all just going to get shredded, and I'm going to grab a couple of sentences and I'm going to put those into my article. But it sure would have been neat to have that. In fact, it would have been even better to have it on video so people could see it like an interview, kind of like what we're doing right now. And so you can kind of imagine, part of my plans as well is to try and put as much of that stuff that we do and make it available. And so people can, you can read the article if you want, but you can also just see the video that served as the basis of that article. And you can hear the words right from the astronaut's lips or the head of the space agency or whatever. Because, I mean, we talk to these people all the time. And yet, people don't get a chance to sort of see who they are and what they have to say. So that's, again, that's part of the plan. I mean, part of the big problem right now is it's all so new. Nobody has the technology. And so a lot of the times, I try to be a journalist, but I really end up just being tech support.
Right.
Do you have a camera? Is it plugged in? Do you have a USB headset? Okay, great. No, I'm still getting some audio echo. No, I'm still getting some echo. So that's, as soon as we can get past that stage, I think, things are going to be great.
Yeah, and I think, more and more often, at least people have a laptop or a computer that has a built-in webcam. So if nothing else, you've got your camera available to you. We're coming to the end of the hour here, and I was wondering, I just wanted to to play this really fast. There was a post on your website, Universe Today, about a Stephen Colbert PSA for NASA, and I just wanted to quickly play this and see what you think about Stephen Colbert pitching for NASA.
Hello, I'm Stephen Colbert. I've always been a huge fan of space. I love looking up at the stars and wondering what distant planets are still out there to be discovered, and can we frack them for methane. And now I love space even more because NASA is doing great things at the International Space Station. Besides working around the clock to create new flavors of astronaut ice cream, Come on, caramel space chimp swirl. They're also developing new vaccines for things like salmonella, MRSA, pneumonia, and hopefully whatever disease makes our astronauts move so slowly in space. Please give generously. If you'd like to learn more about how NASA is improving our lives, visit www.nasa.gov. Or as they say in space, these aren't the droids you're looking for.
That cracks me up.
He's a total space nerd. I mean, you know, whenever it's one of the times when he kind of breaks characters, when he has guys like Neil deGrasse Tyson and stuff on, and he can't help himself but completely nerd out about space. He's got a treadmill named after him on the space station. So
that's right.
He's serious. He's legit.
He's legit, and yeah, having people like Stephen Colbert promote NASA. I think it's all right. I think it's a smart move on NASA's front as well.
Yeah, absolutely. He has a ton of guests, space related, science, that kind of thing. So yeah, I don't know. It's great.
I was just talking with some people on Google Plus actually earlier today. Something came up about lightsaber wars with Stephen Colbert and anyway, I'm going to try and pitch the idea to Stephen Colbert that we have a guys versus girls lightsaber battle to prove once and for all who is better at science.
Death by lightsaber. If you're able to make those kinds of pitches to Stephen Colbert, then awesome.
I'm just putting it out there right now.
Yeah. Next time you hang.
So, female and male scientists with lightsabers needed. We are going to we're going to try and get Stephen Colbert to take this idea.
I don't know if you noticed, but on our weekly space hangout, half of our team is female. It's half male, half female.
That's great.
Yeah. So, I mean, we've got Emily Lakdawala and Pamela Gay and Nicole Gallucci and Nancy Atkinson. It's actually a very balanced team.
I am glad you're out there promoting astronomy sciences, and doing it in a balanced way. Giving men and women a voice through your hangouts. Girls and boys, we can hang out. It's okay.
More girls in science.
Yes.
That's what we want.
Yeah, more girls in making it into science careers. That's what we want. Anyway, we are at the end of our hour. This went really quickly. It was really, really fun talking to you.
Thanks for having me.
You're welcome. Thank you so much for joining me. I will see you on the internet. I will see you in Google Plus. I will be there. I feel like part of this program has been a promotion for Google Plus.
This episode brought to you by Google Plus.
I know. Okay, where's my money?
Yeah, money, please.
Exactly. Anyway, if anyone is interested in finding out more about the universe, astronomy, Fraser Kane, you should visit universetoday.com or astronomycast.com and check out the things that he does out there. Do you have a Twitter account?
It's Universe Today. Yeah. And then I have a Facebook that I never use.
And Google Plus.
But yeah. And Google Plus. But Google Plus is the place, and that's where I'm most active and, try to participate as much as I can.
Awesome. Yeah. Awesome. Thank you very much once again, everybody. I'm Dr. Kiki. This has been Dr. Kiki Science Hour, and we have come to the end of our hour for the week once again. Next week, we're going to be talking about animals, epidemiology, and disease. That's right. Who's on the front lines of figuring out what the next big plague is going to be? Veterinarians. That's who. We're going to talk about that a bit. I'm Dr. Kiki. You know that. You can follow me online. I'm Dr. Kiki at Twitter, Facebook, fan page. I'm Kiki Sanford on Google+. You can head to my website, drkiki.tv. Occasionally I post things there, and you can email me if you want to get in contact. Email me, drkiki@drkiki.tv. If you want past episodes of this show, head on over to twit.tv/Kiki. And they're all there. Or you can go to YouTube and watch them at YouTube. YouTube is great for watching the video version. I will see you next week. Thank you very much for tuning in to the Science Hour. Remember, all I ask is one little hour a week. And I do hope that this hour makes your world a whole lot more interesting. And now for your science meditation of the week.
I'm Maria Zuber, Principal Investigator of NASA's GRAIL mission. GRAIL is the first planetary robotic mission that includes an imaging experiment that's devoted entirely to education and outreach, called the MoonCam system. This video clip was made by Ebb as it flew above the surface of the moon that we don't see from Earth, from the North Pole towards the South Pole. The far side of the moon is extremely rugged. The surface also contains many impact craters, which are preserved features from asteroids that hit the moon's surface after it formed. The MoonCam investigation will begin in March, when middle school students will have the opportunity to target interesting areas of the moon that they want to study. So stay tuned.
The GRAIL mission. I'm very excited about seeing the far side of the moon and investigating and finding out what people find. Not the dark side of the moon, the far side of the moon. Just to get that straight. Even though everyone loves Pink Floyd, you need to be accurate here. Right, Fraser?
Yeah. I like to burn Pamela with that one. I'll say, the dark side of the moon, see if she catches it.
See, how many times exactly? How many times does she catch you doing it?
Yeah, not enough. Too many times.